Alrighty, class, lesson 63. This is called changing rates. We have done plenty of work with rates. The concept really started with unit multipliers, unit conversions, where we wanted to convert distances maybe from inches to feet or inches to yards. Later we did sometimes we converted maybe square inches to square feet. And remember there, we needed to use sometimes 2 unit multipliers. Okay, if you recall, a possible unit multiplier would be that there are 12 inches in 1 foot, and then we would flip it because there's always 2 possible unit multipliers, depending on the answer you're looking for. And we would flip that, and the corresponding unit multiplier would be in 1 foot there are 12 inches. So we'd have this one and this one. Okay, when you have a rate, there's always 2 possible rates, the one rate and then the inverse. Okay, or the flip that fraction. Another one we worked with things like, Ben can shovel 10 sidewalks in 6 hours, things like that. Most recently, we worked with speed, rates of speed, and the distance problem. They told us that whenever you have a rate with time on the bottom, that's speed. Consider that speed. For example, miles per hour. Okay, and so here I have a rate of speed, 60 miles per 3 hours, but typically we don't like to see that with 3 hours on the bottom. It's always good to have that with a single unit of time, so we don't say things like, I'm driving 60 miles per 3 hours. We would say, I'm driving 60 miles per 1 hour, or rather 20 miles per 1 hour, or I'm talking at 1,000 words per 1 minute, something like that. So it's always good to go ahead and do the division and make it per a single unit of time. So we would take this speed here, 60 miles per 3 hours, and we would actually call that 20 miles per 1 hour. And that's how we like to work our problems, is with single units of time on the bottom. So, all right, so when you have unit of time on the bottom, that's considered speed. So here, we're working with the same idea, rates of speed. But in the problems, they're going to ask you to change the rate. So you're going to have to know how to set up the first rate. They're going to tell you how much it changes, and you're going to have to write your 2 rates based on that change. All right, let me give you an example. I'm going to use the example from the book here. I'm sorry. This is example 63.2, I believe. The machine could cap 500 bottles in 2 hours. If the rate of the machine were tripled, how many bottles could be capped in 10 hours at the new rate? All right, step 1. Find your first 2 rates at the original speed. All right, let's look for our information. 500 bottles, 2 hours. So we write that like so, 500 bottles in 2 hours. Sorry for the sloppy writing. We always flip that to get our second possible rate, 2 hours. We can do 500 bottles. Our second rate there is not considered speed, right? This one is speed because it has what? Time on the bottom, right? That's our speed. At any rate, no pun intended, there are 2 possible rates, 500 bottles in 2 hours and 2 hours to do 500 bottles. All right. Second, we need to make that per unit of one single unit of time. So we want to divide 500 by 2, and that becomes 250 bottles, I'll abbreviate as B, per 1 hour. Okay, that's easier to work with. And then we flip that, and we have 1 hour to do 500 bottles. All right. What is the next thing we do here? Let's read the problem. Okay, we've got the machine could cap 500 bottles in 2 hours. We've got our 2 rates. We've made them into rates with a single unit of time. If the rate of the machine were tripled, how many bottles could be capped in 10 hours? If the rate of the machine were tripled. Let's look at our rates here in step 2, and let's triple the rate. So we're going to go 3 times as fast. So 3 times 250, we're on step 3 here, is 750. If you're going 3 times as fast, you're capping 750 bottles now in 1 hour. You're going 3 times faster. Once again, we flip that and get our other possible rate. Okay, this one, of course, is speed because it has time on the bottom. Now we can solve our problem. What do they want to find out? They want to know how many bottles can be capped in 10 hours at the new rate. So we're going to have to use the rate from step 3. What are we trying to find out? We're trying to find out how many bottles. We want our answer to be in bottles. So we're going to use the rate with bottles on top. That's this one here. So let's write that down. Let's write in our units. Don't forget to write those in. And we are multiplying it by the information given, which is 10 hours. All right. And then now this looks very familiar. We've done this so many times. Shh, quiet in the background, please.
I'm sorry, I'm talking to myself.
It's okay. Cancel hours. Sorry, that was hours. Cancel those. We're left with bottle. And then let's look at our units. We have 10 times 750. That's, we're going to add a 0 times 10, right? 10 times 750 is 7,500 over 1, or just 7,500 bottles. Okay? And that's what you're going to do there. They're going to give you a particular rate. Step 1, you got to pick out that rate with the information given, then write the reciprocal of it. Okay, write the reciprocal here. Get your two rates. Then change your rate according to what they state in the problem. Are they doubling their rate? Are they cutting their rate in half? Are they increasing by some certain number? For example, here they could have said if the rate increases to, there's an extra 100 bottles that they do. Their rate increases by 100 bottles. Well, then I would have made that 350 instead of tripling it to 750. So just be careful to follow the instructions. Are you doubling? Are you tripling? Are you cutting in half? Then, in step 3, based on that, we write our new rate of speed. And then lastly, we answer the question given. Okay. Go ahead. There's 3 examples in the book, and there's 2 practice problems. Please be sure to review the practice problems if you have any questions. All right, signing off.